Bismillahirrahmanirrahim. Lagrangian of a simple pendulum. Lagrangian of a simple pendulum is, as we know, the Lagrangian function is L is equal to T minus V, which is equation number 1. And look at the diagram. Consider bob suspended from extensible string something. It is the original length. When we displace, it will from point O, it will displace to A. It is the length of the original, and when it is displaced, it is the new becoming length. And this is the angle theta. This is the point C, and this is the displacement. We know it is the displacement, not displacement, but actually S is actually arc. Displacement, you will take the theta. Okay, so now there is the differential form of the Lagrangian means the differential equation of Lagrangian as del divided by theta, del L divided by del theta dot is equal to, theta dot means derivatives, and is equal to minus del L divided by del theta. Okay, so when we come from the is equal to the next that one, it will be is equal to that one. Theta is the angular displacement, we already said, and L is the effective length of pendulum. Okay, so arc OA, as you know, arc OK is equal to S. So M, and M is the mass of the bob, already know we. As we know that the from displacement distance per S theta is equal to S divided by L, so in cross multiplication S is equal to L theta. So we also know that the velocity is equal to the rate of change of displacement. So it is the displacement, V is equal to that one. Okay, so when we put the consider that we have to discuss this like be that. So the we know that V is equal to ds divided by dt for derivative of S L theta. So by S we replace L theta. V is equal to dl theta divided by dt. So L will be a constant, and theta we will take the derivative of theta. So V is equal to L into d theta divided by dt. So V is equal to L theta dot. Okay, so now come to the kinetic energy. As we know, kinetic energy T is equal to half mv square. Okay, so now V is equal to 1/2 m in original position. So as we know, the V is equal to L theta dot square. No, so it will be L theta dot whole square. So reply the square. No, it will become T is equal to half m into L square theta dot square. Now as we know, the potential energy P is equal to V. So it will be V. No, then as we know, the potential energy to a certain height of the pendulum, it will be energy equal to mgh. So V will be mg, and to h is the height is represented by F, we represent OB. And OB we will represent OB minus OC, like that. We say OC minus BC. It will be become OC minus BC. After that, the OC represented by L, it is a length up, and also BC represented by L cos theta, it will be the angle. So now we will put the mg, and L will be the common, and 1 minus cos theta, it will be equation 2. So this is equation 3, sorry, and this is equation 2. So put equation 2 and equation 3 and equation 1. If we put that, L is equal to half 1 over 2 m L square theta dot square minus mgl and into 1 minus cos theta. Now differentiate with respect to theta and theta dot. So now we will represent with respect to theta. So to differentiate with respect to theta, and dl is equal to divided by dθ is equal to 0. It will become 0. The first part, it will become 0. Okay, so that will be 0. Okay, so it will be 0, and that will be minus mg. It is the cos theta, so it will be changed to sin theta, because the derivative of cos theta will be minus is equal to sin theta. So it will become dl by theta is equal to minus mgl sin theta. Now differentiate with respect to theta dot. It will be dl divided by d theta minus ml square theta dot square. It is equation B. Now for the equation B and equation A. For the equation B and equation A, we already know the equation A is in the phase number 1, like that. dl divided by dl divided by the theta dot minus dl divided by the del theta is equal to 0. Now put it will become d divided by d theta ml square theta dot and plus mgl sin theta. Now take the derivative. ml square, it will be theta dot double dot because it is the acceleration point of view plus mgl sine theta. Now take the common ml, that will become l theta plus gl sine theta dot. Now it will l theta plus l theta dot plus g sine theta is equal to 0. Now both side divided by l, if we take divided by l, it will be theta dot plus l will be divided by l, so it will be vanish. So plus g divided by l sine theta dot is equal to 0. So this is the Lagrangian of a simple pendulum. The equation of a motion of a simple pendulum by Lagrangian, it is proved. Thank you very much.